Yeah, hi guys, welcome to the present session or the present class. So I hope that my audio and video both these two are fine, right? So from the past 2 days, I used to tell that in the starting of my video that I am going to start the one UGC Net Electronic Science course. So it is the pamphlet of that one, and here I may check down. It is the Intense Super 30 UGC Net Electronic Science course. So here the paper one as well as the paper two, both these two we are going to discuss. Okay, so one is a morning session and one paper is at the evening session. So daily almost we are going to spend, including the both paper one and paper two, almost more than 2 hours. And here there is a 100% money back policy is also there. What it means is that whatever the topics I am going to cover in this course, if those topics are not up to JRF cutoff score, then your money will be refunded. So I'm having that much of confidence that if you well prepare about the concepts, the topics, okay, whatever we are going to see in this course, then definitely you can crack the UGSNet JRF. Okay, I'm going to cover the complete topics as per the to crack the JRF, but rest of the part depends upon your preparation or the practice and all. Fine. So if you want to join in this course, then first of all, WhatsApp me to the provided number, that is 8639439984. I will send you the rest of the details in 1 week. Okay, and then we'll in after 1 week, whatever the details I'm sending, we'll see about the rest of the things. Fine. So first of all, if you are interested, then express your interest by texting through the WhatsApp. Okay. So daily we are going through each and every one topic as a name of the basic electronics. So in this video, we are going to see one of the UGC net previous year question. Okay, so one question I took. So it is the UGC net June 2023 question it is. Got it? UGC net June 2023 question it is. And today we are going to discuss about the topic behind this question, not just simple it is the answer and it is the answer. So what is the topic, okay, behind this one, and how can we understand about the topic also, we will see in this video, right? Okay, so let's start. And before starting this session, one small announcement is that if you are seriously preparing for the UGC Net Electronic Science, then don't forget to subscribe this channel, and after subscribing, tap the bell icon also, and share this YouTube channel link to your friends or colleagues, whoever preparing for the UGC Net upcoming examination. So I think all of you are very much aware about the UGC Net examination. Why? Because if you once crack the UGC Net JRF, then you are going to get the very good stipend. Nowadays, the stipend also increased up to 37,000 like that. So that is the importance and significance of the UGC Net JRF. Okay. So a well practiced and well planned preparation is very, very important. That definitely we are going to get that well planned preparation from this Intense Super 30 UGC Net Electronic Science course. And only 30 members I am going to take. The to the first 30 candidates I will take. And 31st candidate also I don't accept. Why? Because if the class strength is less, then I can able to focus more, right? Okay. So while coming to this question, in case of the reverse bias to photodiode is kept in the dark condition, the current flowing through the devices corresponds to. See guys, basically we are having the, if you are taking the optical communication, then we are having the optical sources. Okay, from the optical, that means to the optical source, we are giving the electrical energy. We are giving the electrical energy to this one. Okay, and whatever the electrical energy we are giving, it will be converted into optical energy, and this optical energy transmits through the optical fiber cable And here optical detectors will be there. Optical detectors will detect the optical energy which is coming from the optical fiber cable, and the optical detector output is again electrical energy. It will be amplified with the help of the amplifiers, and then the message, original message signal, will be detected in the physical format. Okay, so it is how the optical communication can be defined. And whatever the things I explained here, out of all these things, optical sources means the examples can be taken as light emitting diodes and the lasers. Okay, so here light emitting diodes works based upon the spontaneous emissions, based upon the spontaneous emission of light. And here the definition of this one itself, light amplification by stimulation emission of radiation. So here stimulation emission of radiation will takes place. So basically that is the difference between the LEDs and lasers. LED is the spontaneous emission of light or the radiation, and in the lasers stimulation emission of the radiation will takes place. The difference between both these two we'll see in the upcoming parts. Okay. And while coming to the usually optical sources are also called as a sensors. Okay, sensors means which converts the one form of energy into another form of energy. In this case, the electrical energy is converting into optical energy. Coming to the optical detectors, usually we can take that avalanche photodiodes. Okay, avalanche photodiodes, or simply we can call as a photodiodes also. So, or else photo transistors also we can take. Okay, so these are the different types of devices which are used to detect the optical signal, and they will convert the optical energy to the electrical energy. So optical detectors also comes under the sensors. Okay, fine. Now one more point you have to understand is that whatever the optical sources we are taking, LEDs or the lasers, usually we will forward bias the optical sources. But while coming to the optical detectors, means all these things what we are doing the reverse biasing. Okay, that means optical detectors work when you are doing the reverse biasing only. It is a very important point that everybody has to know. Okay, fine. Now the question is about the photodiodes. Okay, it means optical detector related question it is. And of course, I already told you that optical detectors must be in the reverse biased condition only. So that is what they mentioned here. Now you may get one doubt that, sir, what happens if the photodiodes are forward biased? If the APD or PD or the PT are forward biased, they just acts like a normal conventional PN junction diode. Normal conventional PN junction diodes. Means, actually optical detectors are used to detect the light, right? If you do the forward biasing means you don't get that functionality. Okay, detection of the light will better happens only in the case of the reverse biasing. The same thing also we can explain here. Why don't we reverse bias the optical sources? Means in order to transform the electrical energy into optical energy, reverse biasing will not properly helps to get the enough amount of optical energy. The forward biasing only will helps. Okay, fine. So now coming to this photodiodes, let's discuss about little bit regarding this photodiodes construction in a simple way. So let's take the diode as like this, and it is a P and it is a N, right? And let's take it is a depletion layer of the PN junction diode. I think all of you know that whenever the two different extrinsic semiconductors are connected together, then definitely one depletion layer will forms. Okay, so whenever the optical energy projected here, or else whenever the depletion layer is exposed to the optical energy, now as I told that photodiodes, what we do the reverse biasing. So reverse biasing means connecting the P type to negative and connecting the N type to positive. So if the light is not there, that means if nothing light is exposed on the junction, now what is the current flowing through this diode? Okay, usually we can take it as positive to negative. Positive to negative, as we already discussed about this positive to negative and negative to positive concept in the previous video on the name of original current direction and the conventional current direction. Okay, so usually the current will flows, I mean, let's take the current flows as like this from positive to negative. It is called as a conventional current direction. And now, if nothing light is exposed to the photodiodes, whatever the current is flowing through the PN junction diode, in the case of reverse biasing, it is called as a reverse current, right? It is called as a reverse current. Usually, if the diode is forward biased, then the current flowing through the diode can be taken as a I is equal to I naught into e power V by eta Vt minus 1. We'll take as like this. And here I naught is the reverse saturation current. V is the voltage drop across this junction. Eta is the intrinsic factor. It is equal to 1 and it is equal to 2, depends upon the silicon and germanium. Vt is the thermal voltage. Later in individual basic electronics series, I will discuss about the individual videos. Okay, fine. So if I do the reverse biasing, means the reverse current will flow. How can we mention the reverse current means? So we will represent the I naught. Usually the I naught is in the reverse direction. So that's why I will take the minus I naught and e power V by eta Vt minus 1. So we can take it as a like this. Right? So it is a reverse current flowing through the diode. And if you take here the V suffix forward biasing voltage, here V is a forward biasing voltage. In the case of reverse current, V suffix reverse biasing voltage we can take. That is a minute difference with respect to the what we call formula representation. I hope you understood. So the reverse current can be expressed as IR is equal to I naught into, I mean, minus I naught into, and the reverse voltage, right? So minus V divided by eta Vt minus 1. So it is a reverse current flowing through the diode and it is a forward current flowing through the diode. So coming to the photodiodes, as I told that we are doing the reverse biasing and it is a current flows. Okay. Now, whenever the nothing light is exposed to the junction, then what will happens? The normal current will flows to the diode. It is a normal current, normal reverse current flows to the diode, right? Whenever the light is exposed to the junction, then what will happens? If the light is exposed to the junction, then the photons are hitting the junction of the photodiode. Whenever the photons are hitting the junction of the photodiode, then the photons energy will transfer to the electrons or the atoms present in the junction. Are you understanding? Photons energy is transferring to the atoms present in the junction. Now, whenever the photons energy is transferring to the atoms present in the junction, then the free electrons will be released. This free electron concept also I told in the yesterday video. The name of original and conventional current direction. So a lot of free electrons will be released. Now, the number of free electrons depends upon the number of photons projecting on the junction. So now the reverse current without light, it is simply called as a reverse current. And after light is exposed, then now the reverse current plus photon current, both these two will be there. Now the total current flowing through the photodiode after exposing the light will be very, very high. Got it? Okay. So if the illumination is more, then the free electrons will be more, then your total current will be more. So, okay. So photon current will be more, it leads to total current will also be more. So it is how we are going to define. And now whatever this IR is there. Now what I told, IR is nothing but a reverse current flowing through the photodiode if the light is not there, if the light is not exposed to the junction. And it is also called as a dark current. The name itself clearly justifying, right? Dark current means no light exposed on the junction of the photodiode. It is called as a dark current. Okay, so now let's go to the question. In case of reverse biased photodiode is kept in the dark condition, the current flowing through the device corresponds to, now you guys tell me, in the dark condition or else in the dark, I mean, here they mentioned as a dark condition. In the dark condition, the current flowing through the photodiode is called as a what? Dark current. Correct? Dark current. And once exposed to the light, then the photocurrent also added to the dark current, then it leads to the total current. So now what will happen? Maximum value of current will which can flow through the device. When the maximum current will flows whenever the IP also added. Correct? Whenever the IP also added, then the maximum current will be flowing through the diode. So when the IP current adds, whenever the light is exposed. Okay, whenever the junction of the PN diode is exposed to the light. So here maximum current will not flow in the case of the dark condition. Value of reverse saturation current, of course, it is equal to the value of reverse saturation current. Next, normal value of current, we cannot take the normal value of current. Okay, and next one is 0. It never be 0. Okay, it never be 0. And why we are taking as a reverse saturation current as a most apt answer, because we are doing the reverse biasing. So whenever we are doing the reverse biasing, then automatically it's equal to the value of the reverse saturation current. So that's why the most suitable answer is the second one, and we can take here option 2 is the correct answer. Okay, so I hope that all of you got some new points, okay, from this video with the help of this question. So here this question is explained with the help of the optical communication brief block diagram, and in this one, what is the role of optical sources, what is the role of optical detectors, and how they have to be forward biased. Okay, and while coming to the optical detector, PD photodiode, how come it is going to work whenever the no light is exposed, whenever the light is exposed. Okay, how come about the equations regarding this one. So everything we discussed. Okay, so with few more concepts, we will meet in the next video, guys. And I hope that you understood. If you are having any queries regarding this one, then you just post your query in the comment section. Okay, and before finishing this video, one more time I'm reminding that if you are seriously preparing for the UGC net electronic science examination, then this course will be really helpful. It is only for the starting 30 number of candidates. There is a 100% money back policy, and you may express your interest by texting or WhatsApp to this provided contact number. Thank you very much. We'll meet in the next video.